In this podcast, we are learning all about angle bisectors. In angle bisectors, obviously, you need an angle, and then you have to bisect the angle. So let's see what that's going to look like. If I were to take just a random angle, I'm going to call this angle ABC. And E is just a point somewhere on there, and it looks like D is somewhere in the middle of that. Okay. What I want to do is I want to select a point that is the same distance from this segment as it is from this segment. Now, in order to do that, I need to remember how to measure distance from a point is to a segment. So if I were to take that point right there, and I were to measure how far this point is away from there, I am not going to choose a distance. I'm not going to use my ruler like that. I'm not going to use my ruler like that or like that. As a matter of fact, I can show you how I will use my ruler. If I have a ruler right here, to measure the distance this point is away, I'm not going to take my ruler and measure, let's say, I don't know, that distance. That looks like about 3.8, but I am not going to say that that is 3.8. The reason why is that is not measured perpendicularly, because what gives you the right to measure it at 3.8 and not, let's say about, 3.7. So which one's right, 3.8 or 3.7? Or even if you take your ruler like this, couldn't you have also measured like that and measure, 4.7? So which one's right? Well, the one that's right is the one that gets measured perpendicularly. So it has to form a right angle there. Now, in order to do that, you have to have a right angle. So therefore, you would construct, blah, blah, blah. You would measure the right angle. So let's go back to our drawing, and we see how this works. So if I want to select a point, so I'll pick a point right there. I have to construct, so from there to there, I'm going to construct a perpendicular line, and I'm also going to draw a line from there to that intersection where those intersections are. Now if I can measure that, I can measure the length of that, and it is 2.14. But if I do the same thing over here, and I measure from that point to that segment, I have to construct a perpendicular line, and then I draw the line from G all the way to that intersection, and if I measure that length, 5.36. So now the issue is, where do I move that to where they're going to be exactly the same? Well, close, close, close. You could pull your eyeballs out of your head if you sat here long enough, and this is only supposed to be about a 4-minute podcast. So what I want to teach you to do is if you were to just construct the angle bisector of that. So angle bisector, angle bisector, angle bisector, and here it is right here. Show the angle bisector. Well, that's intersection F, sorry. Hide intersection F. I want to show this angle bisector. So how I'm going to do that is I want to show the bisector. If I were to put that point right there on G, then that and that are going to be the same exact distance as that. Oh, I know it's 3/100ths of a little bit off, but I think you understand the point. So let's go back, and what I'm going to do is hide all the stuff that I just did. So I don't want to turn that. I want to hide the bisector, and I'm going to select all of that, and just action button, hide show, and hide all those objects there. So what I'm going to do is I'm going to construct the angle bisector. Here we are. So now if I measure from how far D is from there, that would be a perpendicular line. This is what I've been trying to do, that angle F. So as you see, as I move D to F, that's how that works. So if I were to measure it is from D to F, it is that long right there. So it's 5.79. But if I wanted to measure how far it is from E to D, if you'll notice, from E to D, so E to D, it's getting shorter, 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 shorter. Then it passes F, where they're at the same, and then it keeps on moving. Now it gets bigger, 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 bigger. So the realization is that if I draw any point perpendicularly, see F gets smaller, 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 which would then, you would have some sort of line doing the same thing here, perpendicularly, and so as you move to that point, that would always be congruent to that, that making this, some sort of weird shape this would always be congruent to this, obviously, which would make this congruent to that, which gives you, congruent triangles again. So there's a whole lot of craziness happening in there. And that is how angle bisectors work. Thank you very much.